Good morning. Today we have exercise 15 on the book. It is exercise 15, page 28 on the book. In exercise 15 we have to use the notes in the previous video. In the equation x squared minus 8x plus 8 equal to 0. Calculate m so that the roots x1 and x2, when they exist, verify the following condition. In each part we should take a condition different from the other one. First, he say when they exist. So in order to talk about the roots should be exist. What do we mean the roots should be exist? Then delta should be greater than or equal to 0. So first step, we should calculate delta, and then we look at the condition in each case. Delta equal b squared minus 4ac. Here is the equation. We have a equal to 1, b equal minus 8, and c equal to m. Now we will solve many exercises about parametric equations. What do we mean by parametric equations? Equations contain an unknown, which is the parameter m. Delta equal b squared minus 4ac equal minus 8 squared minus 4 times 1 times m. Then the answer will be 64 minus 4m. We should take delta positive. Delta positive, since the roots exist. To see where this is positive or where it is negative, we should make a table of sign. How we make table of sign of a polynomial? From the previous period, we take 64 minus 4m equal to 0. 64 equal to 4m implies that m equal 64 over 4, it's equal 16. Now we will take a table of sign. Minus infinity plus infinity. Here we have 16. Now we know where first this one is equal to minus 4m plus 64. What is the coefficient of m? It is negative. We put opposite sign. This is delta. Delta, in this part it is positive and in this part it is negative. We will keep this answer for the parts below. Part 1. x1 equal to x2. What do you mean by x1 equal to x2? It means that it is a double root. If we have double root, then delta will be equal to 0. Where is delta? It is minus 4m plus 64 equal to 0. Then m equal 16. So the question is calculate m if x1 is equal to x2. Then m is equal to 16, since delta is equal to 0. Second part, we have x1 equal 1 over x2. 1 over x2, then it means that the roots are here reciprocals. So we will have two conditions that are delta should be positive, and if delta positive and the product is equal to 1. The first condition gives us delta positive. From the table of sign, we have that m belongs to minus infinity 16. Why it is minus infinity 16? Here is the part where delta is positive. What do we mean by p equal to 1? The product is c over a. C over a equal to 1. C over a, it is m over 1 equal to 1, implies that m equal to 1. M equal to 1 Is m equal to 1 in this interval? Yes, it is in this interval, since here we have 16 and here we have minus infinity and here we have 1. The first one, it is minus infinity to 16. This is the interval minus infinity 16, and 1 is included in this interval, so it is accepted answer. Part 3, we have 1 over x1 plus 1 over x2 is equal to 3. When we are talking about roots, then we should find them in terms of s and p. We can multiply first one by x2 and second one by x1 to get same denominator. Here we will get in the denominator x1 times x2, and in the numerator x2 plus x1 equal to 3. x2 plus x1, which is s, over x1 times x2, which is p, equal to 3. Now s is equal to minus b over a. From the equation minus b over a, it gives 8 minus 8, which is 8 over 1, then the answer is 8, and p, it is equal to 1. We calculated it before. Sorry, p is m over 1, which is m. p is equal to m. Then 8 over m equal to 3. By cross multiplication, 3m equal to 8 implies that m equal to 8 over 3. Now, this is the first condition, and we are talking about roots, then delta should be positive. Delta is positive for m belongs to which interval? Minus 8, 16. This is the first condition, and the answer is 8 over 3. Is 8 over 3 included in this interval? It is included. You can make sure of this one by calculator. It is less than 16, then this answer will be accepted. Here we have exercise 20, page 28. Given the equation of the second degree, here we have the equation in m, where m is a non-zero real parameter. M is a number different than 0. You can see a equal to m, b equal minus 2 times m minus 1. It is the coefficient of x, and c is equal to m minus 7. Calculate m so that the roots of this equation exist. When he says the roots exist, then delta should be positive. We should see where is delta positive. So first step, we should calculate delta. Delta will be, the answer will be containing m, of course. b squared minus 4ac equal b, which is minus 2 times m minus 1 squared. This is b squared minus 4 times a times c equal. Here we have minus with even exponent, it will become plus. So the answer will be 2m minus 2 squared minus 4m times m minus 7. Here we will make a remarkable identity, a squared minus 2ab plus b squared. This is a squared minus 2ab plus b squared, and here we have expand 4m squared plus 28m. So we will cancel 4m squared by minus 4m squared minus 8m plus 20m. Then the answer will be 28 equal 20m plus 4. This is delta. Now we want to see where is delta positive. So we should make a table of sign. To make table of sign, we should calculate the root of delta. we put it equal to 0, then m equal minus 4 over 20, which is equal minus 1 over 5. Table of sign, here we have minus infinity plus infinity, and here is the root minus 1 over 5. The number which is multiplied by m, which is 20, the coefficient, it is positive. We put opposite sign. Then the answer will be delta positive. Roots exist when delta positive. When is delta positive? For m belongs to minus 1 over 5 plus infinity. Part 2. Calculate m so the roots of this equation are opposite. He is talking about the roots. Then first condition, delta is positive. Second condition, when the roots are opposite, then the sum will be equal to 0. The sum of the roots is equal to 0. Delta positive, we already calculated it. M belongs minus 1 over 5 plus infinity. S equal to 0, we find S, which is minus b over a, equal to 0, implies that minus 2m minus 1 equal 2 times m minus 1. We cancel minus by minus, over a, which is m, equal to 0. Cross multiplication, then we get 2m minus 2 equal to 0, implies that m equal 2 over 2, it's equal to 1. Is this number included in this interval? It is yes, so this answer will be accepted. Of course, here we have this is a closed interval, not open. In part 1, it is a closed interval, since greater than or equal to 0. He said roots exist, not distinct roots. Part 3, he asks, can these roots be reciprocals? Reciprocals, the condition of the reciprocals, delta should be positive and the product is equal to 1. This condition, m belongs minus 1 over 5 plus infinity. Product is equal to 1 implies c over a is equal to 1. From the equation, c is equal to minus 7 over m equal to 1. Cross multiplication, we get m minus 7 equal to m minus m minus 7 equal to 0. We cancel m by m, then we get minus 7 equal to 0. We get an impossible result. This is impossible. Minus 7 equal to 0, impossible. So he asked, can these roots be reciprocals? We get an impossible result, then no. The roots can't be reciprocals.